For those of you who are attending today, I see we have a good few people. My name's Richard Fennell. I'm the Engineering Director of Black Marble, who are a Microsoft Gold partner in the UK. Much of our work is based in collaboration, so we write systems often using SharePoint and BizTalk, and so today Typemock have kindly invited me to come along and do a session on how we use Typemock Isolator to speed our SharePoint development. I hope you find it all interesting, and I see no point in hanging around, so let's leap straight into the session. What's the big issue when developing for SharePoint? Well, the fundamental issue is it's a big and complex infrastructure. It stops us being reactive to what we want to do. To do anything in SharePoint takes a while. So for an example, what I'm going to do is talk about a system we wrote a few years ago for a company called Prontoprint. Now this is a franchise organisation that deals with printing. So you take in your CD full of printing material that you want, your new brochure or whatever, and they'll print 1 million copies for you or whatever you need. So an important thing for them is for you to be able to find a branch. So they decided to completely re-engineer their whole system so that it was working on SharePoint 2007. This was a complete infrastructure change both for internal use and their public-facing internet. And one of the features that they wanted was a web part that they could reuse on the site that would show people where their nearest store was. And you can see a screenshot of it there. Now, this is a web part. It uses Google Maps to display it, which you may recognize. It uses a SharePoint list that stores information about all of the centers. So for every place you see one of the sort of purple squares with a P in it, that's where they have a branch. And if you click on that branch using JavaScript, it pops up a balloon that gives you some details about the branch, the address, the phone number, all those sorts of things. Now, all of those details, the location stored as a GIS location, and a email address and all of those things are stored in a SharePoint list. So what this web part had to do was access data off a SharePoint list and then render it using JavaScript. Now, to do that, there's a couple of requirements. One is we need to be able to see Google Maps. Well, we can't really do that much about that. We need an internet connection. The other one is that we need access to a SharePoint list to store the data. Now, as soon as you need a SharePoint list, historically, that means you need a copy of SharePoint. So as soon as you need a copy of SharePoint, especially in the SharePoint 2007 days, that meant you needed a Windows server with a copy of SQL with SharePoint installed on it and your dev environment, and etc., etc., etc. Now, the way we tended to operate at the time was we would install all of those various items and place them inside a virtual machine, running any virtual machine technology, virtual PC, Hyper-V, VMware, didn't matter. We'd run inside there, and so we'd do our development, and our process would be as follows. We'd write some code in Visual Studio in a project that could create our WSP. Now, because this was in SharePoint 2007, that was all handcrafted XML that we had to use using sort of community tools to help us. We'd then deploy the WSP via a sysadm command or via the UI. Now, obviously, you can write a batch file to ease that process, but you still have to do it. Maybe put it as a Visual Studio post-build step. We can then wait for the inevitable IIS reset, and because you're running on a virtual machine, that can take a little while. We then maybe want to attach our debugger. What we tended to find was it was such a pain attaching the debugger, we tended to use something like Debug View from sysinternals that just monitored the debug stream all the time, and so we ended up debugging by looking at lists of text files and log files. Not the best thing in the world, but we could attach a debugger, but that took another few seconds if you were going to do it. And then finally, you'd actually get round to doing your testing, because if you think about that web part, you're testing something that's visual. And what we found is that most web parts tend to render a piece of information. So they'll render stuff from a SharePoint list or some other service exposed inside SharePoint, or they will gather information that they store in a SharePoint list. So they're mostly render and data capture based. So you do all of that, and that could probably take a minute or 2 minutes to go from pressing F5 in Visual Studio to getting it round to a point where you're ready. So a couple of minutes, and those you do it many, many times a day. It repeats and it repeats and it repeats and it repeats. And those 2 minutes really start to add up. So what we wanted to do was to try and make life easier, to try and reduce that time it was taking. Now, it's important to say here that the tooling for SharePoint 2010 is much better. You don't have to handcraft your own XML from the red box at the top. The deploy, the WSP, it's still deployed as a WSP, but it's done by Visual Studio for you. There's still a fair chance it will cause an IIS reset when you do it. The debuggers can be attached automatically. You don't have to run SharePoint on a server-based operating system anymore. You can install it on Windows 7 or Vista and use that as your tool. So all of that process is much improved, but it's still sluggish. It still takes a little while to deploy. And half the time, you're not that bothered about SharePoint being there. Because if you think back to the web part that we were on before, it's showing you data. I'm worried about whether the little boxes are in the right place. I'm worried whether the JavaScript pops up the right bubble or not. I'm not really worried about any core piece of SharePoint functionality. Now, what we'll see in this session is that there's a number of ways you can address this problem, but the primary one we're going to do is we're going to use Typemock Isolator to remove our dependency on SharePoint at runtime. Now, as I say, there's ways you can tackle this problem by designing your code in different manners, but there's also ways that you can apply clever tooling to actually allow us to remove that need. So the essence of this is, wouldn't it be so much easier if we could avoid using a SharePoint server to develop our SharePoint web parts? And the answer is yes, you can, but we have to use some mocking. But what is mocking now? I'd normally do a show of hands at this point, but that's obviously quite hard on the web. So what I'll do is I'll be going through the basics of mocking here and as to how it's actually important. So the first thing is, when people start to talk about mocking and this general area, they tend to talk about stubs and fakes and mocks. I think too much can be drawn into trying to decide which is which, and you'll sort of draw some techniques from all of them. Now, if I get this one right, it's a stub is something that will just return a bit of fake data statically. So normally you call a database, but now you just call a text file that renders the rows of data in. A fake is like a lightweight implementation of something. So you are going to use a big database with lots of features, but you have a smaller version of it that just does a few bits. And then we get to a mock, and a mock is something that allows you to test the fact that certain calls were made onto your fake test mock stub system. So that's the sort of space we're looking at. But why is this sort of technique important? Well, it allows us to isolate our production code and our testing code from the underlying systems. So if we wanted to write some unit tests to test our production code, and our production code used 3 different things. It used a database, well, that database could be SharePoint. It used log stuff to some sort of log file, and it used a web service to talk out to services out on the internet, and we wanted to test that. Well, that unit test has some problems, because for any unit test, we want the system to be in a fixed state when you're starting the test, so you know what your test criteria are. But it's plausible to get a database into a fixed state, but you might have to restore it or throw away transactions or something. There's complexity. You if you're logging service, well, it might just be the case that for logging, you just have to delete the old log file prior to starting. That's sort of quite reasonable. But if you want to check something against the internet, well, you've got a bit of a problem. It's quite hard to get the internet rolled back to a certain state. So what you want to do is try and isolate everything. So by using a mocking layer, we can fake out all of those items. We can create a fake database, a fake logging service, a fake web service, and our production code doesn't know. And if we do it correctly, the swapping out is not the onerous task of having to reconfigure your whole system. In fact, we should be able to control that mocking out from within our unit tests, so the production code doesn't have to alter. Now, you're probably thinking at this point, well, yes, if I do good design, I can go and do this all myself. Some of you may be a step ahead and thinking, yes, well, we'll do all of that with interfaces. And then we have different instances of interfaces, and that'll all be good. And that's true. That's exactly right. You do use interfaces. But the problem that you have is if you've written something that's got a big complex interface, maybe it's got 100 methods on it, you need to implement your test version of that, and you've got to implement all those methods. Now, if you're using something like ReSharper or DevExpress, CodeRush, it'll write much of that boilerplate code for you. It'll create an instance of your a class that implements your interface, but there's still work to be done in there. So this is where auto-mocking frameworks, of which Typemock is one, come to play, because they remove the need for you to write all of the bits before you start. It allows you to dynamically create them at runtime, and it's all done using reflection and clever stuff behind the scenes. Now, there's many frameworks out there, therefore the larger players in there. You might be wondering, why am I talking about Typemock? Well, the fact it's a Typemock webinar might be part of the reason, but the main reason is we select Typemock for one reason, and that is because it will allow you to mock out sealed private classes. The way I like to put it is, all of the mocking frameworks other than Typemock play by the rules. They only allow you to mock what the .NET framework says you should be allowed to mock, i.e. interfaces, unsealed classes, that sort of thing. Typemock Isolator does all of that and does it really well, but it also allows you to intercept calls to create a fake instance of classes that have no public constructor, that aren't interfaces. And that really comes to the fore when you're dealing with SharePoint, because SharePoint is effectively a large collection of sealed private classes with no public interfaces. So, enough about talking on that. Let's have a look at some of these bits. So, right. So here we have a solution. So I'll just go through it and explain what we've got in here and what we're going to be having a look at. We've got some business logic in this system. And initially we're just going to have a look at the basics of I'm sorry, I'm just getting a few bleeps in there. Sorry, I should have. Yes, so what we're going to be doing is looking at the basics of mocking first. So, what we want to be able to do is, if we've got a class in here, we can pass in interfaces. We can pass in interfaces, and we can change the behavior of the class in production. So what we have here using an inversion of control type pattern is that we can pass in an interface that will provide access to our data source, and we can pass in an interface that will provide access to our email service. This means we're able to fully test a set of calls like this. So it's probably easier to talk about that and actually show how it's done. So here I have just an ordinary Microsoft Visual Studio 2010 test project. I'm going to be using MS Test today. There's no reason why you can't use any testing framework you fancy. It makes no difference. So I'm going to add a new test in here. I'm just going to add a basic unit test. So I've got an empty test method there. So I've got an empty class. I'm just going to write a test that will allow me, without using a mocking framework, to test this class. So what I'm going to do first is I'm going to add a test. So I'm going to add my test, and I'm just using DevExpress Code Rush here, so you don't have to watch me type. So first I'm going to put in a test, and I give an expressive name. So an email is sent when a client order is processed. That's what we want to check. I'm then going to add in some methods. So first I'm going to add in that I need a test data provider. And I need to add a reference to my business logic first. So that will work. So projects, I need to add a reference to my business logic. So that should now. No, is that not happy? No, I need my test data provider. Sorry, I've put it in the wrong class. So what I will do is I'm just going to, in best tradition, I'm going to use one that I've already started earlier. So I'll just add a new test class in here instead. I'll do it that way. So I'll add a new unit test. I do exactly the same. This one's got all the references in place already. So I add it in. I add in my first item, my second item, and my fourth item. I should now be able to add my references to these. So what have I got here? I know I need to pass in a couple of interfaces, my iData service and my iEmail service. And in this class, I already have pre-prepared, which is what I forgot to copy over, a sample of my test data provider. So for my database one, see, I've created an instance of it, and I just return a few standard methods. But I've had to write that. For my email provider, I don't want to send an email, that's a bit of a pain, so I've written something that basically intercepts the calls to send email, and then it adds an accumulator and just counts. So then if we go back, it's the wrong one, isn't it? Sorry. Oh, if I just closed the wrong one. Sorry. Let's do that again. So we have those. We then actually want to put in our test that we want to run. So what we do is we're going to call our new order processing object. We're going to pass in these two fake data items, and we should be okay. And then we're actually going to do an assert at the end to check how many times the email was called. We should expect to see it once. So I'm using some good practice here to actually get in to actually do all of that. And that's the one I should have closed. So I should now be able to build that. should be able to build it now. And I should be able to run the test, and I'm just using test driven here to run it. So this is a very fast look at how you would normally write the using the manually mocking. So that's one way of doing it. So we've actually gone in and we've had to hand create our test provider, we've had to hand create our test email provider, and we pass them in. Now if we wanted to use a mocking framework, and we'll use Typemock here, we can do that. So what we'll do is we'll just delete that class. We'll bob it in again as a, I've got two test methods there, haven't I? And so here, what we'll do is we'll set it up in a slightly different manner. So what we're going to do is we're going to use Typemock. So first, instead of us having to handcraft the, I'll just add the references, handcraft our implementations of our two interfaces, we can just tell Typemock to go off and do it. So Typemock goes off, so we're saying Typemock Isolator, please create me a fake instance of my business logic interface. So behind the scenes, it's gone off and it's created it. Now we can actually pass some parameters in here. I haven't needed to do it, but we can. And the parameters that we've got are, we can pass in the member. So if we look at members, we can see there that we have 4 options. We can tell it to call the original, so we could tell it to actually call any method that's inside here. Now that doesn't really help with interfaces because interfaces in .NET have no implementation, but if we were creating a fake instance of a concrete class, we could do that. We could tell it to always that we have to specify any other return value for any sub-object that's in there, or we can tell it that we can always return nulls or always recursively fake. I've left it at default, which means if you find anything underneath this that you need to fake it too. That should be fine. We then need to add in the fake item that we need. This is what we're going to return, so we need to create a piece of business logic that we're actually going to return. We then need to set our behavior, and this is where in the past, if you were creating it by hand, you would have to go off and have to create your own class and your own implementation. This is where, with Lambda expressions, we can go off and we can set the behavior automatically. So what we're going to say here is, right, when there is a call on the fake data object with the profile of get client with the parameters, please return this fake object. When there's a call on the get orders for client method to stringed, return those words, email body. So that's fine. We then need to add in our call. So we need to just move that up. We then call our IOC container. See, we haven't changed the production logic at all. We're still calling the same piece of business logic. We're just passing in the new fakes. We then need to pass in, actually call our method. So we call our method in exactly the same way as we did before. In fact, it's exactly the same line. We call T5, but now we have some extra options for when we want to validate what's happening at the end, because Typemock provides us with tools that allows us to go off and say, right, please validate that this method was called with exactly these parameters. So you see, before we could have written something that did that. We could have gone off and done all of that, but it would have been quite a lot of effort, and it'd be very specific to one test, and you can end up spending more time writing your test implementations than you do your production logic. So by using an IOC framework, we can just choose to implement what we need just for this test at the moment of runtime, and because it's nicely performant. So I can now just run that test, it will force a recompile, and it will go off and run. Hopefully it come back fairly sharpish. And that's all well and good. But that doesn't really help us when we want to check something that doesn't have public methods. So if we go back and look at the business logic and look at our legacy code, I bet you've all got code that looks more like this. So there's our legacy order processing. We don't pass anything in. You see, we just have embedded in here that we're going to call a send email method, and the send email calls bits and the client process. There's no way to get in there. So it's very problematic to test. We can't swap things out, but that is still testable to us by using the features of Typemock. So if we go back, and I'll just quickly go through this, and don't worry if you're thinking about SharePoint, I'm just trying to set the scene still here, because this bit that we're about to use now is the technique that we use far more for dealing with SharePoint. So, but it's just a bit clearer to do it without bringing SharePoint in straight away. So we create our test again. This time we're going to do it on the legacy one. We still want to call the same method in the end. That's the thing we're testing, that we're testing our order processor, but we need to set it all up. But we want to do it in a way that we can get at the legacy system. So here we create a couple of objects that we're going to return. We need to create our fake processor this time. You see, this time, instead of faking out the instances of our interfaces that we pass in, this time we fake out the instance of the piece of business logic. So here we're saying, please create me a fake instance of our legacy order processing class. Now this is where Isolator can do this and the other mocking frameworks can't. And what we're saying is that actually still call the original method underneath. We're just going to intercept certain bits of it. We then need to set some behaviors on that. So what we're going to say is, right, when somebody calls the non-public method called getClients, return the fake client. When they recall the non-public method called getOrdersForClient, return the fake order. And when they call the send email non-public method, just ignore it, but you still count that it actually happened. And then we can actually then set some results down the bottom, so we can verify that those methods were called. We can verify that the method was called or was not called, if that's appropriate, if there's logic in there. And we can also check that the send email was the correct parameters were passed to it. So we should be able to run that now. Just kill code rush has gone away. And there our test should run, and hopefully it should pass. Now obviously here, if you're doing TDD, you should always write tests that fail first, so you can see that they're passed, but we're obviously a bit pushed for time here. So if you do want to see that the test is broken, you know, if I change something in there and run the test, there we are. We have a mismatching exception error in there. They don't match, so we can drill out and get that information. So what does that mean? It means that if we've designed our code nicely using interfaces and all those sorts of patterns, we can use Typemock to go in and within our tests dynamically create the test instances of our underlying data structures. That's really useful. But if we've got a nasty piece of legacy code with no way to inject things, we still have a mechanism for getting in there, for faking out a class that was never designed to be mocked, for intercepting private methods and putting our own behavior in so that we can better test something that's historically untestable. So what does that mean if we actually want to test some SharePoint? So what we'd like to do now is actually test a SharePoint project. So if we go over and have a look in here, we've been looking at our business logic. If we look in our web parts, we have here a simple web part. Now, for any of you familiar with SharePoint, this was originally targeted at SharePoint 2007, but it will work on any of them. So what do? We know there's two major methods we're interested in. There's the get child controls call, and in there we go in, we build a table, we apply some CSS classes to it, and then we start to add rows to it. And how do we add rows to it? We do fairly standard SharePointy things. We connect to our current SharePoint server. We grab the current web we're on. We go and get a SharePoint list based on a parameter that's been passed in. Our data list is declared up here. There's our data list. It's a string property, so we pass in a name. And we iterate around it, adding rows to a combo box. So that's all well and good. And normally what we'd have to do here is we'd have to build that, we'd have to deploy it, we'd get a WSP, and as I said before, and all that sort of stuff. But we'd like a way of working on that without that delay, so we can get a really quick look at it. The other method that's in there that there isn't too much in there is the render method. We quite often have things in the render method in a SharePoint web part. You may have other methods in there, but they're your two key main ones. So what we want to do is we actually want to be able to run that and test it. So what we'll do is, again, I have down here a website, just an ordinary website. I'm just going to add a new page to it. So new item, and we're just going to add a ASPX form. Now the trick here is that ASPX pages are quite capable of hosting web parts, as I'm sure you are aware, but they're not capable of being SharePoint. They're just web parts. So they're just web pages. So what I'm going to do is I'm going to put enough HTML in here to ooh, why has that failed? Luckily, I have one that I prepared earlier. So what I'm going to do is, because this is standard code, I'm just going to cut that over. That's all that macro should have done, was insert that code. So I'll just go through it. So we register a web part that we're interested in. We have all of our normal HTML headers, and then the important bit is here. We add an ASP.NET Web Part Manager, and we add a web part, and we add in our simple SP web part, which was the one you saw we were just looking at up there, simple SP web part. You might ask, why are you doing this all declaratively in HTML? The reason is, if you do it declaratively in HTML, there is no need for the ASP page to spin up a copy of SQL Express to do the web part personalization. It will just work. If you try and do this from code behind, it causes personalization to kick off, so different users see different things. Doesn't mean you can't use that technique. It's just I've found that by doing it declaratively in here just makes life easier. Just makes it quieter, calmer. So we've added all of that. We go, great. There's our page. It's been saved. I can now open that page in a browser, and it should launch our web part. Just make sure this renders on the right screen. There we are. It's rendered on the wrong screen, but let's just get it to the right size for you. There you are. So there we are. We can see we've called our new web page, and it's running off a local copy of Cassini down here, dev web server. Now, what I will point out there is I'm running on a 64-bit box here, and Cassini is by default 32-bit. Some of the techniques I'm talking about here do get a bit confused between 32 and 64-bit, and you really do need a 64-bit web server. There's a link at the end of this session that goes to a blog post that explains everything about that and how you can make Cassini run in 64-bit as opposed to 32-bit, and then all of your problems go away. But the main point is here, I'm loaded my web part, and it's come up and it's giving me errors. Now, one thing I do when I'm working with SharePoint is, because SharePoint is quite good at swallowing errors, you'll notice that I put a nice big generic try catch in the render method and a nice big generic try catch in the create child controls, so I guarantee it will render something. Too many times in the past I've had problems where the thing hasn't displayed and you're going, well, did the deploy fail? Which page failed? At least with this, it might be ugly, but at least I do actually get something back. So you can see there, it's failed. And if you start to look at the error, we're starting to see what our error is that it's asked for a URL to do with the SharePoint site. Well, we're not on a SharePoint site. Of course it's going to fail. That sort of makes perfect sense. So if we go back to our web part here, what can we do to fix that problem? Well, the first thing we do is we go into the code behind, and you don't go into the designer file, you go into the CS file. It would make far more sense, wouldn't it? And we go into the page load event. So we can use the features of Typemock to address that. So first thing I'm going to do is I'm going to set the name on my web part to the name of the list that I'm interested in. So, what is this test helpers class? Well, this test helpers class is one I've already got sitting inside my web part, and all it does is the Typemock things that we saw in the previous test. So there's the first one that we've looked at. I've set a static string. But then it says, right, we know we're going to have to call the URL, because if we go back and look at our web part, you can see, what does it do? Well, it gets a URL by using all that sort of stuff, and then it does stuff with SharePoint lists. So that's the sort of thing we've got to fake out. So if we go in here, oh, sorry, I meant to go in there. We come down, we have something to create the fake URL. So we use the functionality of Isolator. So Isolator, when called, Microsoft, SharePoint, Web Controls, SP Controls, get context. We pass in null because we don't care. It doesn't matter what context you pass in, you're going to return this value anyway. We say, please return this URL. And our URL is http://mocksite.com. And we also have something for faking out our SharePoint site. So, and this is where it starts to get clever. First, we fake out an instance of our SharePoint site. Now, as I remember, there is no public constructor for a SharePoint site. So this is where we're trying thing already. That's why we create a fake instance. We then use the extra magic command that's in Typemock Isolator, and that is to allow you to swap in to the running application the fake you've just created. So we say, when somebody next asks for a new SP site, i.e. when new SP site is run, no matter how, inside the system, don't give them the one that should normally come off the framework. Give them this fake one that we've just created. And there is also a swap all instances. You find you need the swap all instances far less often than you would expect. Swap next instance is normally fine for most things. We then say, well, actually we want some test data as well. So we want a collection of SP list items. Now again, I can't remember if there's SP list items have a constructor or not, but we create, first thing that we do is we create just an ordinary list of them, because I certainly know that when you ask for SP list items, you get back a collection of SP list items that is a special construct that definitely doesn't have a public constructor. But we just want to sort of group some together for now. So we're just going to stick them in an ordinary generic list. And then we're just going to use a for loop to create some data. And again, there's no public constructors for these things, so we fake out a new SP list item. We add it to our collection, and then we set the behavior on the item that we've just created. So we say, right, if anybody asks for this column title, return title, and we just add in a number, so 0, 1, 2, 3. If they ask for an email address, we say their email address is email123@email.com. So we've just set some behavior on there. Now you can make that behavior be driven from a Excel file if you wanted to, or a text file, or whatever. Doesn't matter how you set that behavior, you can set it to anything appropriate. And Isolator knows what the return type is. In this case, they're both strings. But if it needed a complex object returned, like we saw in the previous example where it returns a fake client object, well, it knows that it has to return a fake client object. It has to return Boolean. It knows that in that field there must be a Boolean. That works really well. So we're building a generic list of these items, all with their own behaviors. We then use another really useful command. We set a behavior on our fake website. We say, right, if someone asks for the fake website's web root for a specific list that matches the string that's hard-coded at the top, and we ask for the items in it, well, we know that's going to return an SP list item collection. Now, we don't even know how to construct one of those, but we don't have to, because Isolator gives us this really useful call. We don't want to do a returns. We don't want to do a will return. We do a will return a collection of, and we pass in our ordinary generic list of SP list items, and Isolator will convert it to being exactly the right return type that the system is expecting. So we haven't had to do any work in there. It's all done for us behind the scenes. So those are our two helper methods. So all I'm going to do is just drop the two helper methods in here. So I call create the site, and I call create the fake URL. If I now build that, just overwrite it. That built. I'm now going to go back to my web browser where I had my error, and with a bit of luck, if I press F5, ta-da, it doesn't error. It loads the page, and it's picked up that fake data. Now, one thing I would warn you here, the reason I said it should there is occasionally sometimes you need to restart Cassini or your web browser at this point. Because it's just got a bit confused as to what's been going on, and it needs to, by stopping it and restarting it, it'll recache any assemblies. I have seen that occasionally. It's very rare, but it always seems to happen when I'm doing demos. So it is always worth mentioning that sometimes you fire it up and go, oh, I'm not quite seeing anything. But you do another refresh and it's fine. And then after that, it's fine. So you can see here, I'm picking up all of the information. I'm picking up my faked site. I'm picking up my 3 rows of data. I'm picking up that, and if we wanted to change that, if we went back into our Typemock sample and went into our fake site method, and we change that from a 3 to a 13, and we build it, finished, yep, go back in again, I'll refresh that. Got our 13 rows, 0 to 12. So you can see the basic idea is there that we can replace any information, but you also saw that with Isolator, you can go in, you can also validate that calls are made back the other way. So you can see that if this was a form where somebody filled in details and pressed a submit button that called code behind the scenes that wrote to an SP list item, you could create your fake SP list item with Isolator. You can write all your data to it using your production code, and then at the end you could validate that the data is there. So you can still remove that behavior. You might be thinking, well, that's all well and good, but how does that help? Well, let's have a look back at that web part that we started with. So if I open, see that this is the production site for the web. So if I go into here and I type in, where shall I try? I'll try Black Marble's address. D19. See, it's leapt round, it's taken us somewhere. I can click on there and it's brought up some details and it tells us where the British pronto print is. That's all well and good and lovely, and it's working really nicely. But if I want, when I was writing this, there's an awful lot of JavaScript going on behind the scenes. And this was written sort of pre-jQuery, so it's got quite hairy stuff in there that's rather nasty. The actual SharePoint bit, the getting the data out the SharePoint list, was pretty trivial. It's a list of 100+ centers, but that's all. Once you've written the thing that reads in 100 rows, it's done and it works. The thing that was the real problem getting this to work was CSS styling that makes the graphic appear in the right place and the little man appear, because there's this style guide of the people around the site appears everywhere, and there's quite a lot of flash and things being used using the same style, so we have to get the styling all right. And equally, there's an awful lot of JavaScript in here that deals with the layers inside the Google API and goes off and does the queries and resolves the postcodes and does all those sorts of things. If you're waiting for 3 minutes every time you want to deploy it, it becomes a pain very, very quickly. You get very, very bored, drink an awful lot of coffee and get even more wired. So what we wanted was a mechanism that was very fast to work. In the same way that you just saw that I changed from 3 to 13 people in that combo box, I want something that's that quick to actually do the same process. So how did we actually deal with that? So if I go over and have a look at location map, this is the way we handled it. Here's our location map web part, and it's got logic in it. And if we go into the map object, we can see that we have bits in here for the create child controls and the render method. And there's lots of stuff in here, and it's ugly and not great. And there's helper methods that do stuff, and there's all sorts of nasty string building going on. I wouldn't say it's constructed in the best manner, given a bit of hindsight, but it's in a manner. So what we did was we used exactly the same model to create a test harness. So if we look in the test harness here, we see it's exactly the same. We register the web part. We then have exactly the same construct in here for putting the data up, and we just have a few other little helpers which we see. And then in the Scratchpad's constructor, yep, there we are, Scratchpad's constructor, we don't bother to have helper methods here, we just dropped it all in the constructor. So we put it in, we have an isolate method, so when we ask for the site's URL, we are given the fake web. We ask when we get our context, we return that. We do the same again. We created a fake instance of the map web part. And this time, because we've been playing with a couple of different ideas, there's one way of doing it is to return values as collections, but we also tried doing some tests having things stored as private methods. So you see, either technique is available to us. So what does that mean? If we go to the Scratchpad, we can run it. So if I just view that in a browser, which of course is loaded on the other window again. Again, this is running against a local copy of Cassini. It's never seen a copy of SharePoint, and it's rendered our map. And if we go in and we take one of our sample postcodes, because we can never quite remember them, we hit find centers, it leaps in and it finds one in the center of Birmingham. Notice it doesn't have all of the man round the edge because that's rendered by the parent page. That's actually a thing that's been done by the SharePoint graph designer that's created a page, the web part sits on it. The web part honors SharePoint styles, but it doesn't have to do it fully. It's like on the production site, you've noticed the nice little peas sitting inside little square boxes here. Well, we didn't have that graphic to hand. They're actually provided from the SharePoint site again, just as being an asset inside a one of the 12 Hive folders. Here, we just use a graphic that somebody drew that was roughly the right size, just so we could see what was going on. And you can see we can come in and we can click on items and we can see things and we can check all of these various bits work. So what it means is while we're fiddling with this, our process to fiddle with it is, oh, quick, go in, work in here, save, go back to our browser, refresh. So it's very fast, it's very responsive to work. If we want to attach a debugger, well, we just launch with debugging. So if I just kill that session and I just go into here and I just go launch, I don't have to worry about attaching a debugger to any processes. It will just work. It's ordinary standard Visual Studio work. There's no clever SharePoint going on. So the key point and the key takeaway for today is I have managed to remove the need using this to have SharePoint to actually deliver our web part. So that's see, it's loading everything because we're going along. It's just been a bit sluggish to get there. Have we got there yet? That's the wrong one. Obviously, it decided to sit on a breakpoint. Okay, the interest, oh, there we are, there's a breakpoint, that's why it's there. So we now have a breakpoint and we can step in and do whatever we want. So if we start to step in here, we see it's starting to fake the instances out. And you can actually see how SharePoint has faked stuff out as we drill into it and all the various values that have been done. What's worth mentioning is that the initial development of this client was done using the deploy, go around in a circle style method, and it was rather sluggish. A new feature was asked for by the client, and that was that dependent on where you were in the country, the zoom level should change. So when you're in London, I don't know if you noticed that from the previous ones, that zoomed in to a far smaller scale than when you were in Yorkshire, where it was showing two towns that were 10 miles apart, and that's probably not a mile across. The changes to implement this zoom level change were all done in this test harness, and it never saw a SharePoint server until it was released for system integration UAT testing. And we were pretty confident that was going to work because we hadn't had to touch the WSP deployer. We knew it worked in the test harness. What it meant was something that would have taken a few hours to do took a few minutes almost to make the change. We have a very fast, very responsive way of testing, so it removes that delay. Now you can take this a step further. You can use it for testing that things look right. You can use it for testing the things that submit right, and there's no reason why you can't start to wire it into more fully formed unit tests that are automatically run. So if you want to test your web parts as coded UI style tests using something like Microsoft Coded UI or Selenium or any of those sorts of technologies, that is eminently doable by using Typemock behind the scenes to fake out the calls to the underlying SharePoint. If you want to fully automate that, you can look at Ivana, which is an add-in for Typemock that actually fakes out a web server, and you can start to wire it through in that manner if that's what you want to do. What I would say, just in finishing here before I go back, is if I was writing this again, I'm not certain I'd write it in quite the same way. It's really useful that Typemock can fake out sealed private classes, and you cannot get away from needing that in SharePoint. But a lot of the time, you've made matters worse for yourself by dropping all of your logic inside your main create child controls. We started by looking at a class that was well designed and allowed us to pass in interfaces to ease testing. I'd still look at using patterns along those lines to write your web parts. So instead of using this web part, the simple one that we saw before, I would be tempted if, oh, sorry, that's the wrong one, isn't it? the simple one that we did before, I would look at writing my web parts. So they still take the same parameters, but they make use of a model view controller type pattern. Now, I'm not saying use Microsoft's model view controller template inside SharePoint. There are ways of doing that if you want. I'm not saying go out and use monorail. I'm saying use the pattern, the underlying design, saying that you have a controller that contains your business logic, and you have an interface that defines your view, an interface that defines your data, and you vastly increased all your testing options. Because here you then can use the I will mock it out myself method and remove that dependency on SharePoint. You can test your implementation of your SharePoint connector independently by using Typemock to isolate out the SharePoint and test that interface programmatically. You've greatly increased the number of test points, but you can still use exactly the same technique, because if we look back into I have a test harness down here for the, I'll just close that and close that down here with a mocked, there we are. So with the web part, you see, I can still do exactly the same. I can still use exactly the same calls in my faked web part as I did before, because we're still making the same underlying calls to SharePoint. It's just we've introduced many more testing points. Now, I'm very conscious that time's running on, so if I just quickly return to the slides. So, a common question here is, you've been waffling on for an hour about web parts. Can I use this with workflows and event handlers? The answer is yes, but you have to adopt more of the view that I was just talking about with MVC. You cannot test a whole SharePoint workflow using this type of technique. This is because it's not possible to run a SharePoint workflow outside of SharePoint, and I have seriously tried. Basically what happens is you can define the workflow, but the moment you try and run it, if there isn't a SharePoint server as the host for the workflow, it goes into an idle state and won't come out. It's waiting for something that we cannot simulate. But what you can do is, if you're writing custom activities into running a workflow, you can test those with this technique. You can take your custom activity, and whenever it talks to an SP list or any of those objects, you can fake that out. So what I would say is, unit test all of your custom activities independently, and then publish them to SharePoint, and then test that your workflows function as you'd expect by testing them using Designer. SharePoint Designer, because workflows in general will be user created based on libraries of items. Event handlers the same. Your event handlers are going to trigger based on SharePoint events, and they'll do something, maybe write something to a SharePoint list. Again, design your event handler logic so you can test them as units without the need for you to actually go on and trigger the event using SharePoint. So there are techniques that can get around there. So, in summary, mocking frameworks provide a valuable tool to improve code quality. Irrespective of what you're doing, have a look at them. You'll find them really useful. In general, they require you to have written your code in a way that allows mocking frameworks to be used, but Typemock Isolator gives you a huge step over that it can go and mock legacy code, as I showed, to get around the problems of historically poor design for testing. Isolator gives you lots of extra tools for legacy, and more importantly in this case, for complex platforms like SharePoint, where it's just not designed for testing. We can replace that dependency on SharePoint and simplify what needs to be on a developer's PC, but more importantly, vastly increase their productivity, i.e. they can get the stuff that they can do a F5 dev look, have a look cycle in 1/10 of the time that it would take if they're using a SharePoint site that they have to deploy to. And though the benefits I found huge in SharePoint 2007, they're still there in 2010. It still allows us to reach a place, especially where you're doing a lot of client-based activity in your browser. It really is very productive. So you're not thinking about Isolator as a way to enable unit testing, you're allowing it to enable design. But no framework's a complete solution. Typemocking and its tricks are no excuse for poor design. So if you can modify your design to make your life easier, do it. If you can modify your web parts so they use an MVC-like pattern that means you don't have a dependency on SharePoint for testing, that's great because you've now removed the thing that you need to test into a small unit that you can test in an automated manner without a UI using Isolator to fake out SharePoint within your build device. So still think about designing for ease of testing. Don't rely on the fact that Typemock Isolator allows you to do things that doesn't make you feel right. You really should try and use it in a manner that still gives you well-designed code that is easy to test, resilient. So there's trial versions of Isolator up on the Typemock website. There's a blog post on that link that will go through all of the stuff I've been talking about today. There's also, I mentioned that there's a problem with 64-bit assemblies on 64-bit dev boxes when you're doing this sort of stuff. So I did a blog post on that as well as to what you need to do to get around those problems. My contact details are there, so if you have any other queries, please don't hesitate to ask. The source code for these demos is